Assalamu alaikum. This is Javed sir with another video lecture for 9th class. As you know that in our previous lecture we discussed the necessary condition for the existence of relation of congruence between the two triangles. And in that lecture we have learned that if we have to bring two triangles in the relation of congruence with each other, then the 6 parts, that is 3 sides and 3 angles of one triangle, must be equal to the corresponding 3 sides and 3 angles of another triangle. Say if we have triangle A, B and C, D, E, F as two triangles with us, as we know that AB corresponds to DE, BC corresponds to EF and AC side corresponds to DF side, and angle A corresponds to angle D, angle B corresponds to angle E, angle C corresponds to angle F. Now to make these two triangles congruent, the corresponding parts must be equal. That means if we take this AB as 5 centimeter, this AB corresponds to DE, then DE should also be of the same measure, that is 5 centimeter. BC, if this BC is 6 centimeter, this BC corresponds to EF, then EF should be of 6 centimeter measure. And this AC, if this AC is 7 centimeter, as it corresponds to DF, then DF should also be of the same measure, that is 7 centimeter. Now as for angles, if angle A is 70 degree, then angle D should be of same measure, that is 70 degree. Angle B is 60, then angle E should also be of the same measure. If angle C is 50 degree, as it corresponds to angle F, it should also be of the same measure, that is 50 degree. And if we summarize these equalities between the corresponding parts in this way, we can write side AB is equal to DE side, side BC is equal to EF side, side AC is equal to side DF, and angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Based on the equalities of these corresponding parts in between the two triangles, we can write that two triangles are congruent to each other. This was all about what we have learned in our previous lecture. Now we'll move on with the same concept, and today in this lecture we'll discuss some rules, or we can say criteria, for the existence of relation of congruence between two triangles. Though we know that the necessary condition for the congruence is that all the 6 parts of one triangle must be equal to the corresponding 6 parts of another triangle. But these rules suggest us that if we have to make two triangles congruent, we need not to show the equality of all the 6 parts. But if we are able to show the equality of some particular parts in between the two triangles, then the remaining parts will simultaneously get equal to each other, and then two triangles will be in the relation of congruence. Now, as for the rules, we have five number of rules with us, that is side angle side rule, angle side angle rule, side 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 rule, angle angle side rule, and the fifth one is right angle hypotenuse side rule. Now first we'll write what these rules actually suggest us, and then we'll take these rules one by one and we'll write what are their statements and how can we make two triangles congruent based on these rules. So these rules suggest if three particular parts of one triangle are equal to the corresponding three parts of another triangle, then the remaining three pairs of parts between the two triangles simultaneously get equal to each other, and then the two triangles are congruent to each other. Now we'll take this rule number first, that is side angle side rule. This actually side included angle side rule, and we read it as SAS rule or side angle side rule. Now it states that if two sides and included angle of one triangle are equal to any two sides and included angle of another triangle, then two triangles are congruent. That means if we have two triangles as triangle ABC and triangle DEF with us, and in triangle ABC, AB is 5 centimeter, BC is 7 centimeter, and in triangle DEF, DE is 5 centimeter and EF is 7 centimeter. Now first you can see that in these two triangles, two pairs of sides are equal. That means AB side of triangle ABC is equal to DE side of triangle DEF. BC side of triangle ABC is equal to EF side of triangle DEF. Now we have two sides of triangle ABC are equal to two sides of triangle DEF. Now we need to get the including angles also equal to each other. Here in this triangle ABC, we see that this angle B is the angle which is in between side AB and AC. We can say that this angle B is the included angle included by AB and BC. Similarly, in triangle DEF, we see that E is the side included by DE and EF, and we say that angle E is the included angle of DE and EF side of triangle DEF. Now we have already two pairs of sides in between two triangles equal, that is AB equals to DE, BC equals to EF. Then if these included angles of these two triangles respectively, if these included angles are also equal, then according to this statement of side angle side rule, we can say that triangle ABC is congruent to triangle DEF. Say for example, if this angle B is 60 degree and angle E is also 60 degree, at that time we'll get AB equals to DE, BC equals to EF, and their included sides, that is angle B, is also equal to angle their included angles, that is angle B is also equals to angle E. At that time we get two sides and included angle of one triangle equal to two sides and included angle of another triangle. At that time we can write that triangle ABC is congruent to triangle DEF, because by making these particular parts equal, the remaining parts in between the two triangles, that is side AC and side DF, will spontaneously get equal to each other, and angle A will get equal to angle D of triangle DEF. Angle C will be equal to angle F of triangle DEF. So simply by this statement we can see that triangles are congruent. Now if we take another example, say for example we have triangle PQR and triangle XYZ as two triangles with us. Now if PQ is 4 centimeter, QR is say 6 centimeter, and angle Q, which is the included angle of PQ and QR, if this angle Q is 70 degree, and in triangle XYZ, if XZ is 4 centimeter and YZ is 6 centimeter, and their included angle is also 70 degree. Now we have two sides, that is side PQ and side QR, equal to the two sides, that is side XZ and side ZY, equal in between these two triangles, and also their included angles, that's angle Q and angle Z, are also equal to each other. At that time we can make use of this rule and we can simply write that two triangles are congruent to each other. Now important thing over here is that whenever we try to superpose this XYZ triangle on triangle PQR, their corresponding parts must coincide. For that, here PQ corresponds to XZ, QR corresponds to ZY, and this Q corresponds to angle Z. For that, we have to rotate this triangle XYZ about 180 degree, and we'll at that time after rotation we'll get this triangle in this form: X, Y, Z. This is 4 centimeter, this is 6 centimeter, and this angle is 70 degree. And we have this triangle PQR now in the same sense as triangle XZY is the angle triangle XYZ is. So PQR is in the same sense. Now we'll try to superpose these two triangles. We'll take this triangle and put it on this triangle PQR. At that time, vertex X will fall on the vertex P, vertex Z will fall on the vertex Q, and vertex Y will fall on the vertex R. Now, when we try to write the congruence between these two triangles, we'll take in consideration the correspondence between the vertices, and we'll write triangle PQR is congruent to triangle X, as X falls on P, Z as Z falls on Q, and Y as Y falls on R. So we have to write triangle PQR is congruent to triangle XZY. We cannot write triangle PQR is congruent to XYZ, because at that time the corresponding vertices or the corresponding parts of the two triangles will not overlap, will not coincide. Now there is one more important thing about this statement, that is, this statement is taken as the axiom in mathematics. For axiom, we know that this any mathematical statement which we accept without, which we accept true without proof, or in other words we can say we simply accept this axiom on the basis of our notion. And this axiom, which is side angle side axiom or side angle side rule of congruence, this axiom forms the base for the remaining 4 rules of congruence to prove them. And these remaining 4 rules will be discussed in the upcoming videos, and at that time we'll see what these rules suggest us and what are their statements. And till then, stay blessed, stay safe. Assalamu alaikum.